So section 1.7 in pre-calculus is kind of a big variety of lots of different solving. We're going to talk about solving the square root equations and absolute value equations and formulas, again, all of which is a review, but solving's, you have to have some pretty good skills at solving in order to get through algebra and beyond. Okay, so to solve radical equations, remember radical means square root equations. So the first step is to isolate the radical term, okay, meaning get the square root by itself. Okay, so isolate the radical term. Once you get the square root by itself, then you can square both sides. Okay, once you square both sides, you no longer have any square roots, so you can finish solving the equation for x or whatever the variable happens to be. And then once you get a solution, you need to make sure you check for extraneous solutions. Extraneous solutions. And basically the short term for extraneous solutions is extra wrong answers. But by definition, we would say an extraneous solution occurs when you solve the equation and you get a solution algebraically, meaning you do everything right, you solve it correctly, but then when you check your answer in the original equation, it doesn't work, right? You plug everything in and you get a false statement, okay? So if all of the solutions that you get are extraneous, then you would have no solution, okay? So basically that's saying you kind of have to check your work. Now, I don't want us to get too bogged down in this. I really don't want us to have to do a ton of extra computation stuff to check, but you do need to do a quick check. Okay, so let's look at the first example. So step one, get the square root by itself. So I'm going to subtract the 8. So 1/2 square root of x equals -3. I'm going to get rid of the 1/2 by multiplying by 2. So the square root of x equals -6. And then I'm ready to square both sides. And so I'm going to get x equals 36. And I can tell you right now on this one that if I were to check this, if I were to put 36 in for x, I would have the square root of 36 is 6 times 1/2 is 3 plus 8 does not equal 5. So immediately that's an extraneous solution. Okay, so let's look at the next one. Get the square root by itself. So I'm going to have to subtract the 1. So the square root of 3x minus 8 equals 2. Now I can square both sides. So 3x minus 8 equals 4. Okay, so now I'm going to finish solving. I'm going to add my 8 and then divide by 3. All right, so I've got x equals 4. Do a quick check up there in the original. If I put a 4 in for x, I'm going to have 12 minus 8 is 4. The square root of that is 2 plus 1. That works. So hopefully when you check it, it's something you can kind of do in your head. If you can't do it in your head, then I don't want you to spend too much time checking. I just don't want us to get bogged down with that. Okay. Let's see. Let's try number 2. Now, in this case, I have 2 square roots. So when I say get it by itself, well, you can't. So look at one of the square roots. As long as one of the square roots is by itself, okay, fine. You're ready to square both sides. So I'm going to square both sides. On the left, I have to square both the 1/2 and that square root. So when I square 1/2, I get 1/4. And when I square the square root, I just get 4x. And on the other side, when I square the square root, I get 2x minus 2. So basically, I'm going to distribute and solve. So let's see, subtract my x. So x equals 2. Okay. Again, I'll think about a quick check. If I were to put in a 2, I'm going to have 1/2 the square root of 8 equals basically the square root of 2. And believe it or not, when you simplify the square root of 8, this is going to work out. So that's fine. Look at number 3. Okay, here's one where we kind of step up our game. And this is one that would be a little beyond maybe the difficulty that you would have done in regular Algebra 2. Probably would have done it in honors Algebra 2. At least I think you should have. All right. 2 square roots, that's fine. Is one of them by itself? Yes. So as long as one of them is by itself, you're going to square both sides. All right, so on the left, I just have 3x plus 16. Now here's the thing, on the right, remember when you square both sides, you don't just square them separately because it's addition. You have to think of this as when you square it, it's kind of like, I'm going to go up here, it's kind of like taking square root of 3x plus 2 times itself, right? When you square it, that's kind of like multiplying the entire parenthesis by itself. So you could do the FOIL, yeah, but do you remember the shortcut when you square a binomial? Basically, you square the first, and then the middle term, you double the product. Well, 2 times the square root is just 2 square root, and if I double it, I'm going to get 4 square root, and then the last would be plus 4. If you don't remember the shortcut, or if it's too confusing when you have square roots, then just write it out like I did up here and do the FOIL, okay? And so now I'm in a situation where I would normally say, okay, now solve for x, but the problem is you still have a square root. So it's kind of like you have to start over and you have to say, all right, I got to get that square root by itself. Okay, so if I subtract 3x, do you see those are going to cancel? And I will subtract that 4, so I'm going to have 12 equals 4 square root. And I think I'm going to go ahead and divide by 4 to get rid of that. So I have 3 equals the square root. Okay, I've got the square root by itself. I'm going to square both sides. And so I'm going to get 9 equals 3x, which means x equals 3. Okay, should do a quick check. If I plug in a 3, remember you're plugging it into the original before you squared both sides. So the square root of 9 plus 16, 25, that's 5. And on the other side, square root of 9 is 3. Yep, that's going to work. Okay. You know, I think number 4 is going to be just like number 3. You know, you're going to just jump in and square both sides. But since it's kind of like the extra difficulty like number 3, I think I'll go ahead and work it out for you. All right, so when you square the left, you've got your x minus 1. So on this side, remember you got to do the FOIL, so let's practice the shortcut. You square the first, double the product. Well, the product of 1 times the square root is going to be 2 times the square root. And then you square the last. Okay, so let's get that square root by itself. So I'm subtracting x from both sides. I think I'm going to move the 2 and the 1 over. That's 3. So if I subtract 3, I'm going to get negative 4 equals 2 square root. Divide by 2. Square both sides. So x equals 2. So do a quick check. If I plug in a 2 for x, I'm going to get square root of 1 is 1. On the other side, I'm going to get square root of 4 is 2 plus 1. No, that's my solution, but it does not work. I can do a quick check to show that does not work. And since that was my only solution and it was extraneous, I'm going to say no solution. Okay. A little hint I have. If you notice this, notice right here in my solving, when I squared the negative, it became a positive 4. A lot of times when that happens, if you end up squaring a negative and it becoming positive as a part of your solving, usually you're introducing extraneous solutions. I don't know if you remember, but up here on number 1, remember we ended up squaring a negative 6 and we ended up with an extraneous solution. So I'm not saying every time it happens, but pretty more often than not. Okay. Let's talk absolute value equations. Remember the situation on absolute value equations is that you should always remember to write 2 equations. Right? Write 2 equations. And so basically, once the absolute value is by itself, you write your 2 equations, right? So the first one is x minus 5 equals that positive 7. The second one will be x minus 5 equals that negative 7. I think you remember that, right? You write 2 equations. You solve each one separately. X equals 12 or x equals negative 2. And I have 2 solutions. Okay. Now remember up here where it said, even on absolute value equations, really you should check for extraneous solutions. For now, I'm going to hold off on that. And then when I finish all my examples, I'm going to point something out. Maybe we can kind of find a shortcut for all those checking problems. Okay, so let's go to number 2. Remember, before you can write your two equations, you have to get the absolute value by itself. So I'm going to subtract 15 and get 30. And then I'm going to divide by 2 and get 15. So I have the absolute value of 5x minus 10 equals 15. Now that the absolute value is by itself, I can write my two equations. So either 5x minus 10 equals 15, or 5x minus 10 equals negative 15. Remember, you got to get the absolute value by itself first before you write your two equations. That's the most common mistake I see. Okay, solve for x. Let's see, add 10, divide by 5, add 10, divide by 5. So I've got two solutions. Okay, let's go to number 3. Get the absolute value by itself first. So I'm going to subtract 6. Now I can tell you right now, I don't need to go any further. I automatically know there's no solution. Why? Well, by the very definition of absolute value, if I take the absolute value of this, doesn't it become positive? So there's no way that a single absolute value can equal a negative number. It can't happen. So when you notice that, immediately just say no solution. Okay, so look at number 4. Absolute value is already by itself. So let's write our two equations. 2x plus 12 equals positive 4x. Or 2x plus 12 equals negative 4x. Solve each one. So let's see, 2x, I'm subtracting 2x, divide. There's one solution. Over here, I'm going to add my 4x. I'm going to get 6x, move the 12, negative 12. X equals negative 2. Okay, two solutions. You're like, why are you doing so many examples? Just trust me. I'm going to point something out once I get all these done. Okay, let's do one more. So before I can write my two equations, I have to get the absolute value by itself. So I'm going to subtract that 7. So I've got the absolute value of 3 minus 5x equals negative 7x minus 7. So my two equations would be either 3 minus 5x equals what's there, negative 7x minus 7, or 3 minus 5x equals negative of that. But if it's negative of the whole thing, it's going to become positive 7x plus 7. Okay, so let's solve each one. Let's see, if I move my 7x over, I'm going to get 2x equals, move my 3 over, negative 10. So x is negative 5. On this one, I move my 5x over here, and I move my 7 over here, divide, I'm going to get negative 1/3. Okay, so remember we were supposed to check for extraneous solutions. Okay, so I'm telling you, you can just trust me on that. If I check any of these first two, now we already took care of number 3, but any of these first two, both of the answers are going to work. Just trust me, they work. Okay, but on number 4, let's check number 4. If I plug in a 6, I'm going to have, let's see, 12 plus 12 is 24. Absolute value is still 24. That works. But if I plug in a negative 2, negative 4 plus 12 is 8. The absolute value of 8 does not equal negative 8. And so the easy way to check this when you have absolute value is to start by plugging if you have a negative answer, start by plugging it into the other side and see if it gives you a negative, because there's no way that this absolute value could equal negative anything, right? Because absolute value can't be negative. So that means this one doesn't work. Okay, so on number 5, before I start doing too much, so I like to check it right here when I have the absolute value by itself. If I put in negative 5 on the right side, I'm going to have positive 35 minus 7. Oh, that's okay. That's, let's see, if I put in negative, that's going to be positive 35 minus 7. What is that, 28? Well, I get the same thing on the other side. I'll have 3 plus 25. Yeah, that works. What about if I put in a negative 1/3? Start with the right side. If I put in a negative 1/3, I'm going to have 7/3 minus 7. That's negative. 7/3 minus 7 is negative, and there's no way the absolute value can equal a negative. So that one is extraneous. Now, look at my box here. What do you notice that's different about the equations, not the answers, but the equations from examples 4 and 5, the ones where we had extraneous solutions, compared to 1 through 3, and specifically we say 1 and 2? Well, what I notice is on 4 and 5, do you see that there were x's on the other side of the absolute value? But on 1 and 2, there were no x's on the other side. So that's kind of a little hint. If there's no x's on the other side, on the outside of the absolute value, you don't need to check it. It's going to work. But if you do have these extra x's, like on number 4 and 5, you have to check it. That doesn't guarantee you're going to have some extraneous solutions, but it's likely that you'll have at least one extraneous solution. So at least that narrows down how often you need to check it. Okay? And then the final kind of solving are these formula problems. And the idea here is this is all about your favorite thing, manipulation. Okay, so if I'm solving for a particular variable, basically that means get that variable by itself. Do whatever solving techniques you have to, when you do things to both sides, add both sides, multiply both sides, to do whatever you have to get that variable by itself. So the other side could be really ugly. Don't care. As long as you get this variable by itself, then you've solved. Okay, so on number 1, if I want to solve for W, I see a couple things that have to happen. I need to get rid of the 2L, and then I need to get rid of that 2. Well, how do I get rid of 2L? I subtract it. So P minus 2L equals 2W. And then how do I get rid of that 2 that's with the W? Well, just divide both sides by 2. So P minus 2L all over 2 equals W. Notice the W is by itself. There aren't any W's on the other side, so I'm done. Okay, look at number 2. If I want to solve for R, yes, I'm going to take the square root of both sides, but before you do that, you want to get rid of the pi. So first get rid of the pi by dividing. Now take the square root of both sides, and you have the square root of a over pi equals R. So remember, there are certain things that you want to do. I just want to point out on this one, because this is a common mistake I see. If you had from the very beginning taken the square root of both sides, you would have the square root of a, but you still have that square root of pi, and then you would have had that times R. And people are going to make a mistake there. So that's why I think it's smarter to get rid of the pi first. Okay. Number 3, you have been doing this since Algebra 1. Remember when you would graph lines, y equals mx plus b, and in order to do that, you had to solve for y? That's exactly what this one is. So if I solve for y, negative 5y equals, you can either write the negative 3x in the front plus 8, or you could have put that minus 3x at the end. It really doesn't matter. I'm going to do it this way because that's kind of how we do it when we're graphing lines. So then divide by 5. So another thing to point out, when I say I'm dividing by negative 5, you can either think of it as dividing the whole thing, that's fine, or you can think of it as dividing each individual term, whatever makes more sense to you. So y equals positive 3/5 x minus 8/5. So I have solved for y. Okay, number 4, I'm going to solve for x. So be careful. A lot of people, I think, are going to start by distributing the 4/5. And there's nothing wrong with that. But if you do, you're going to have like that 8/5 in there. And I don't know, I mean, it's fine, I guess. I think what I would rather do is from the very beginning, why don't I multiply both sides by 5/4? Won't that immediately get rid of that 4/5? If I multiply this side by 5/4, I've got this. And if I multiply this whole thing by 5/4, it's going to cancel that fraction, and all I have is x minus 2. So if I want to solve for x, I could just add 2. X equals whatever 5/4 times y minus 3 is, plus 2. Remember what I said, it doesn't matter how ugly the other side is. As long as you get that variable by itself, you're done. Okay, so number 5, I want to solve for b. And I know what's going to be bothering a lot of people is that 1/2. Doesn't really bother me, but okay, that's fine. Let's say I want to get rid of 1/2. What's the easiest way to get rid of 1/2? Multiply all the way through by 2. So every single term I'm going to multiply by 2. 2v equals BH. Don't forget you got to multiply the BR times 2, right? That got rid of the 1/2. But now, do you see that you have a b in both of those terms? So the only way to solve for b is to separate it from the rest. And the way we would separate it is take it out as a common factor. If I take out a b, I'm going to have h plus 2r. Okay. And then in order to solve for b, I'm going to divide by that parenthesis. So I'm going to get b equals 2v over h plus 2r. Okay. There we go. Now look at number 6. I want to solve for b. So look how many b terms there are. I see 3 b terms. So remember on number 5, when I had multiple terms, I needed to factor it out. So before I can factor out a b, I need to get all my b terms together. So I think I'm going to keep the ab and the bc, but I'm going to subtract that 3b. So that way I have all my b terms together. And I'm going to go ahead and put the 10 on the other side. So it's going to be a negative 10 because it doesn't have a b. Now I can factor out a b from all 3 of those. And now in order to solve for b, I'm going to divide by that entire parenthesis. And so there is my b. Okay. All right, so look at number 7. Ooh, oh man. I'm going to solve for x. Okay. The first thing that really messes with me is all of those fractions over there. So here's what I think I'm going to do. Remember, you can do a little bit at a time, and there's no one right way as long as all of the steps you take are correct steps. You're not doing any kind of bad algebra. I think I'm going to get rid of this 2 first by I'll multiply this entire thing by 2, and it'll cancel. I'll multiply this entire thing by 2. So on the left, I have 2/3 x plus 7/4 equals 6y minus 2. Next, so I'm trying to solve for x. I don't really like the fractions. I think what I'm going to do is multiply all the way across. Do I want to do this? Yeah, I do. I'm going to multiply all across by 12. That'll get rid of all my fractions. So I'm going to multiply every single term by 12. All right, so it's going to be this times 12, this times 12, every single term by 12. So when I do that, over here, I'm going to have 8x. Over here, I'm going to have 21. And over here, I'm going to have, 72y minus 24. All right, so now if I want to solve for x, I'm going to subtract the 21. And then I'm going to divide by 8. You can do it separately or all together. I'll just do it all together just because I've solved for x. It's ugly on the other side, but I've solved for x. Okay, so one last one. So you get, I'm kind of showing you some of these subtlety solving kinds of things, all the manipulation techniques that you haven't used for a really long time, or maybe never even thought about. I don't know. Okay. Number 8. I want to solve for n. So I need to kind of assess the situation. I see 2 problems. One is that I have multiple n terms, but I know how to handle that. I just get them both on the same side and factor it out, right? The second problem, though, is one of those n terms is in the denominator. I do not want it in the denominator. I can't factor from both the numerator and denominator at the same time, right? So the first thing I'm going to do is I'm going to think of this as kind of like being over 1, and then I'm going to cross multiply. So I'm going to have I times Rn plus A. I'm going to go ahead and distribute. So I, Rn, and then I times A. So that was me multiplying this side. And then on the other side, 1 times Pn. Okay, now it's kind of like number 6. If I'm trying to solve for n, I want to get the n terms on the same side. So I think I'll move this one over. I'll leave the IA on the right side. I already had Pn, and I'm subtracting IRn. So remember, if I'm trying to solve for n, let's separate it by factoring it. Okay, I know this is ugly. And so now I can solve for n by dividing by that entire parenthesis. So n equals IA over P minus IR. So again, it's ugly, but I've solved for n, and that n is all by itself. Okay, so that's kind of all things solving.